Hi, my name is Yunisha. This is a topic of assignment of statistical modeling. It's a topic 5. So for this assignment, starting from task 1 related to hypothesis, firstly, I got one data set in Kaggle, which was pretty much large. So I samplized it to include only 1,000 females and 1,000 males, so that even after the removal of outlier, I'll get enough data set as required for this task. So after the outlier removal, we can see that I have 801 male and 801 females on this data set. So firstly, I calculated the two sample t-test data. I received the t-distribution value as 7.76 and the p-value of 1.29 into 10 to the power minus 14, which is lesser than 0.05. That proves that there's a significant difference between mean weight of male and female. And I did the visualization of distribution of weights by gender for the male and female. That's all for the task 1. And for the task 2 of the correlation coefficient, firstly I describe about the correlation coefficient and the Pearson, and I implemented the Pearson coefficient, so I have explained about it as well a little. And I grabbed and I got the result set after the Pearson correlation at 0.3524 and the p-value of 2.31 10 to the power minus 50. So the value for the correlation coefficient is pretty much lower and in the positive value, so we can say that this is a pretty low positive relation between height and weight. And with the p-value of less than 0.05, we can say that this correlation coefficient is statistically significant. So this is the visualization. If we see the data is distributed and doesn't show any linearity or specific correlation, so that's why we got this low number of correlation coefficient. And for the task 3 of the linear regression model, I use the OLS, ordinary least square model, to derive the linearity model. So with this model, I received the intercept value as minus 22.86 and the height of 0.58 or the slope of 0.58. So I also derived the summary report from this data set, and it provided the R squared value as 0.124 and the probability of statics value as 2.32 to the power 50, with the standard error for intercept a pretty much higher number with 6.3, and for the height or slope is 0.038. And the condition number I received is pretty much higher if we see here, and also an alert for there might be a strong multicollinearity in this data set. So I have explained everything over here, and I added the regression line with the help of the information I received up here in the same scatter plot diagram. Now to resolve the multicollinearity, let's confirm whether there's a multicollinearity or not. So I gathered I plotted the VIF model for this multicollinearity, and if we see the weight and the height, their values are pretty much higher. So that definitely suggests the multicollinearity between height and weight. And for the solution of multilinearity, I implemented the weighted least square method, which is usually used for the solution of heterodasticity, but I wanted to implement it here, whether it will work for multicollinearity or not. And fortunately, it worked. As we see, we don't see any alert over here. And the standard error R square value, probability of statics value has improved pretty much with a pretty much higher number. So we can conclude that the implementation of weighted least square method resolves the issue. And for the tax number 4, multiple regression model, I combine the age and height into a same data using column stack function, and then implemented the same linear regression model. The R square value I obtained here is 0.972, and the S statics is lower than 0.00, and the standard error is 0.1013 and 0.000 for both for age and height. So since these values are pretty much lower, we can say that this is a good indicator of this model being a fit. And this is the visualization, 3D visualization of height, age, and weight. And since I didn't get any error message for the multilinearity, collinearity, I did the residue plot to detect the heterodasticity. And if we check here, the data set seems to be pretty much normal. The residue plot seems to be pretty much normal, and this concludes that it hasn't violated the assumption of the homostaticity. And for the tax number 5, solution for 2 common assumptions of linear regression. Firstly, I have explained about the 2 linear assumptions. And then a solution to assumption of violation, I used another data set that might be more effective for this task. So I downloaded a data set with this species of fish from the Kaggle, and I got a output of like this on this data set. And this in this data set, I created a visualization, and the data set is pretty much linear. Um, and I did the residue plot for the heterodasticity. And if we see the residue plot, it's a cone shape. So we can see that there is a presence of heterodasticity on this data set. So I try to implement the heterodasticity consistent covariant matrix HCCM to solve this issue. So with implementation of HCCM, if you see the note section here, we can see that I have implemented the heterodasticity robust SC1. So with the implementation of this model, the value of coefficient, standard error, t value, p value, and the coefficient confidence interval has improved from the results that I had obtained earlier. So definitely HCCM will be a solution in the presence of heterodasticity on this dataset. So finally, for the nonlinear model, I implemented the same dataset in the tax1 as suggested, and derived the results for it, and also created a visualization. If you see the visual, the nonlinear line is pretty much close to the linear one, since my data set is pretty much linear. So I try to compare both the linear and nonlinear regression values. This pretty much like the values are almost similar, but if we go into the specific details, then a linear regression model is exhibiting more clearer data. That might be due to the distribution of my data set, due to the character of my data set. Probably if I would have used some other data set with a more nonlinear character, then the values probably would have come for the would have come better on the nonlinear regression side. And I have explained those things over here as well. Finally, here are the references that I used while working on this assignment. Let me quickly go through the Jupyter Notebook, since I have gone through everything on a Word file. So firstly, I imported the data for tax number 1 to 4. I imported the data and removed the outliers and did the hypothesis test and created a plot for this hypothesis, and then evaluated the correlation value and plotted the scatter plot for that. And for question number 3, I did the linear regression, derived this model summary, and then plotted the regression line on the scatter plot and used the VIF model to detect the multicollinearity and propose a solution of the multicollinearity. And for number 4, I did the multiple regression model. I combined the height and edge stack and then evaluated the summary. And after that, plotted the 3D graph and then the uh, residue plot, proving that the assumption of homodasticity has not been violated. And for number 5, solution to the assumption of violation, I downloaded another dataset from the Kaggle and then derived the model summary. After that, I plotted the values and then plotted the residue as well to detect the heterodasticity and implemented the robust heterodasticity HCCM to check for any improvement in the values. And then after that, lastly for the question number 6, I use the polynomial regression and derive the values, derive the summary report for the same, and also plotted the nonlinear regression line. And I have also included the references on the Jupyter Notebook as well. That's all for this assignment. Thank you so much.